Welcome to this tutorial about orders of reactions. I know the calculation becomes pretty straightforward once you're confident with it, but there is a one specific type of exercise that is pretty challenging, even if it's one of these orders, calculation. And I'm going to show you right away. So I'm talking about these exercises where all of the concentrations are changing and you don't know exactly how to find the orders of one if all of the others are changing. So I'm going to show you with an open question the way that I have found the easiest, okay, and also how to write that in like in a format of a 6 marker or even more, as required for the mark scheme, okay, because it is a bit different. So let's get started. I will reveal which paper and which exam board is at the very end of the video, but I want you all to try this question. Okay, I hope you remember my approach if you've watched my videos before. If not, well, give it a try and then you can follow along with me. So I'm going to start now with the solution, okay? And of course, I'm going to look for the easiest thing to solve, okay? And how do I do that? Well, I'm simply going to look at the experiments where as many concentration as possible stay the same. Okay, and that is experiment 1 and 2 because as we see, we see that the concentration of Br changes. Okay, while sorry, 1 and 2 is this one, while the concentration of the bromate and the hydrogen ion stays the same. Okay, so we can see straight away the difference. And I know it's nice and easy to do it here from the table, but remember that in a 6 marker like this one, remember it's a 6 marks question, you can't really show it on the table, but you have to give explanation for the results. Okay, and I'm gonna do it this way. So I'm gonna write it here on the side. Yeah. So for the concentration of bromide, okay, I can see I'm gonna say that I compare experiment 2 over experiment 1. I chose this way around so that I can have full numbers. I see that the concentration of Br minus has been timed by 3. What has happened to the rate? So remember, 7.56 minus 2.52 gives us also 3. Okay, so once we see that the changes are the same, what does it tell us? That the Br minus is, so the rate is first order with respect to the concentration of Br minus. Okay, so this is the first and essential point, and I'm sure that most students got that. Okay, and now things get a little bit more complicated because if you see from the other experiment, there is nothing that stays the same anymore. Okay, of course, we want to find the order of bromate, but as you can see, the concentration of hydrogen will change. Okay, in all cases, I mean, not the concentration of hydrogen, but the concentration of the bromide ion will change, okay, when hydrogen stays the same. Okay, so we can choose actually 2 different experiments, 1 and 3 or 2 and 3. Okay, because in both cases, this change, but the bromate but the hydrogen stays the same. So for sake of simplicity of numbers, I'm going to check, also checking what's happening to the rate. I'm going to choose 1 and 3. Okay, and here just go with your feeling of which number is better. Okay, we don't care about hydrogen, stays the same, so that's great. Okay, and this is to find the order of bromate. So B 3 minus. Okay, I'm going to compare experiment, and in this case, it doesn't matter too much, so like which order you choose, because you will see from the numbers, but I'm going to check, I'm going to do experiment 1 over experiment 3. Okay, and this is where things get a bit complicated, and now I will show you my method. So you see that the rate, like in this case, it stays the same, which is really unusual, but notice that both concentrations are changing. So in order to see the effect that the change of the bromate has on the initial rate, okay, there is one calculation that you can do. And I always like to think it as, okay, I know the rate of experiment 1, okay? I'm going to go off the table. I'm going to go down here just for the space. And as I see that the concentration of bromide from 2 goes to 4, so I know it's been timed by 2. I'm going to write it here. So I know that the concentration of bromide has been timed by 2. I know that for sure the rate it's also going to be timed by 2. And this value is going to give me the rate, yeah, just if the bromide concentration is timed by 2. I can calculate that. So what that's going to be, 5.10, right? 1.4, so 2.52, okay. 0.04 times 10 to the minus 4 is the rate only if the concentration of PR changes. So I can calculate this value, and having this hypothetical rate of the other experiment without the effect of the other concentration, in this case the bromate, it makes it very simple to calculate the order. So if I now look at the rate in experiment 3, the rate in experiment 3, because of the change of the bromate, I will notice something. So first of all, we go from 1.2 times 10 to the minus 1 to 6 times 10 to the minus 1 is divided by 2. Okay, let's write that down. In this case, I know that the bromate BrO3 minus is been divided by 2. And notice what happens to the rate. 5.04 to 2.52 is also divided by 2. So as you can see, we have the same change, but we can calculate that this is the net change. Okay, the net change because I removed the value of the rate that I know it's caused by the bromine. Okay, that's why I kind of go off the table to do this calculation. I'm finding the rate if the bromide, if I take into account the change of the bromide. Okay, so I will see that divided by 2 is the same change as the concentration. So I know that I'm going to write it this way though, that the rate overall doesn't change. It means that it's first order because it's times by 2 because of the bromide and divided by 2 because of the bromide. That's why it's first order, but it's complicated if you don't do it for yourself, actually, this calculation of the table. So it's going to be first order. So I hope you understand that this kind of going off the table calculation. And I would invite you now to pause the video and try yourself for the H plus, because it's going to be a very similar calculation. Okay, and once you're ready, I will go through the solution with you. Okay, I hope you're ready. So there are different combinations that you can try. And that is either like 1, 4, and you notice that it's BrO3 minus that has changed, or 2 and 4, in that case would be the Br minus that also changes, together with the H plus. Yeah, or you can do 3 and 4. Okay, now for simplicity of how I like the numbers, I'm going to do 3 and 4. So I see that the bromate stays the same, so doesn't matter. I'm not going to include that into my, I don't ignore that. Now, do you remember what I did in terms of off the table? Let's do that the same. So we know that also the bromide changes together with the hydrogen, which means that the rate from in experiment 4, okay, so I'm going to start writing things down. In experiment, to calculate the order of H plus, I'm going to compare experiment 3 and experiment 4. What do I notice? I notice that the concentration of the bromine has been timed by 2, divided by 2, which means that for sure, because we found before it was first order, also the rate, I'm going to go off the table. The rate, yeah, from 2.52 is also going to be divided by 2. Why? Because of the bromide concentration. Okay, so this gives us an intermediate value, okay, which is the rate if hydrogen doesn't change at all. Let me get the calculator and let's do it together. If you've done another experiment and you're doing this, 3 and 4 comparison, do the calculations with me. Okay, so the rate changes from 2.52 times 10 to the minus 4 to is going to be divided by 2 because that's the change of the first order bromide. So it's going to give us 1.26 times 10 to the minus 4. Okay, this is the rate, remember, just because of the effect of bromide. Now we can compare how has the rate changed now that we've removed the effect of the bromide. How has it changed with to the rate of experiment for the hydrogen? Has it changed the same way? Let's find it out. As we see from The H plus, it goes from 8 times 10 to the minus 2 and 4 times 10 to the minus 1. Okay, so we need to figure out the change, which has been timed by 5. Okay, what has happened to the rate? So if we go from 1.26, yeah, so 1.26 to 3.15. So I get that the rate from, actually, by the way, I've used this times by 5 so that I don't have a decimal, like, because otherwise it's a bit complicated, okay? But basically the difference, that's why you can play around with numbers. So the difference between 3.15 and 1.26, so as you can see, I've done the calculation actually this way around to simplify it. So this to this has been, no, sorry, actually, this is the correct direction, timed by 5. Let me tidy it up. Okay, so this has been timed by 5. Okay. Remember to play around with the calculator to get the easier number possible. And this 1.26, so remember, intermediate rate. We've removed the effect of the concentration that we know the order of. This, as you will see, has been timed by 25. Okay, so do you see the relationship? 25 is 5 to the power of 2, meaning that it's going to be second order. So hydrogen concentration has been timed by 5, but the rate in total has been timed by 12.5 because it's been divided by 2 and then has been divided by 2 because of the bromine, but has been timed by 25 because of the hydrogen. Okay, which means that hydrogen will be second order. So the goal of this exercise for me to explain is how to write it down, like explain the result if it is like like in this case a 6 marker. Remember the level type of answer has all of the correct orders linked to the explanation, in addition to, of course, the rate equation and the rate constant. Okay, now we can finish off the calculation, but I'm going to show you the mark scheme for you, so you can, if you want, pause the video and compare your answer. Okay, but remember, this is the challenging part, but I like to do this calculation of the table because if you just look at the overall change of the rate and the orders, I don't think you really get the idea of like which is the correct order. Okay. So here is the mark scheme as reported. Remember, it's 6 markers, so it's going to be a level of type response. I want you to get 5 or 6 marks, and you do it by having all the orders linked to the explanations and then rate equations and rate constant. Okay, so I hope you got the correct numbers. So make sure this is all correct, but guys, it's not the goal of this tutorial. The goal of this tutorial is how to deal with concentrations that are always changing, and you need to find the orders. Okay, so if you did the other experiments for H plus or for the bromate, control, like double check your numbers, but overall you should be getting the correct rate equation and the calculation of the rate constant. Okay, so I hope that this is helpful, and if you have any questions, let me know.